Okay, let us discuss this problem 1.266. This is a quite interesting problem. Now this says finding kinetic energy of a crawler belt. So you copy the title, or if you simply copy a number, that's fine. Now let me do anything before, let me first make the diagram for this problem. So this is a surface, horizontal surface we have, and now there is a one wheel of the tractor, this is another wheel of the tractor, and there is a belt that goes over this top. Throughout this belt goes this side, this belt also goes this side. So some part of the belt is the down floor, some part is over this floor on this wheel, some on this side of the wheel. Now this says determine the kinetic energy of tractor crawler belt. So we have to find kinetic energy of this belt. So this part of the belt, some part is hanging here, some part is here, some part is here. So we have to find kinetic energy of belt. Now question says radius of this sphere is r. This a small wheel has a radius r, and the mass of this crawler belt is m. So mass of the belt is m. M is given to you. So this is the total mass from here to here throughout. So this is the mass of belt. Are you getting? Now we have to find out the kinetic energy of this system. Let us say, for our purpose, what we will do is, we will divide this whole belt into three parts. So this part of the belt, that is one part, I will identify this as a, let us say, length is L, and I will divide another part, let us say this part. Call this as A, this point is B, this point is P. So APB part, this part, and the third part I will divide this part, the lower end. Again this has a length L, let us call BC. So what I have done is, and let us say this is CD. CD is equivalent to AB, we will discuss soon. So this is CD. So we have divided into four parts basically, and AB and CD are CQD are similar, and that's why I am saying three parts. So what we have done is we have divided the whole belt into four parts. So we have part AD that has length L. We have part APB that will have 2 pi r by 2, so that is length pi r. Radius is given to you r. Now part BC that will also have length L, and then you will have part CQD that will also have length pi r. Are you getting? Now we will assume mass per unit length. So this length, total mass is m, so I will divide lambda, that is mass per unit length, that is mass is m, and total length is how much? L plus pi r plus pi r. So you will have 2L plus 2 pi r. Are you getting? So this length is L, this is L, so 2L. This is pi r, this side also pi r, so you have 2 pi r. So lambda is mass per unit length, that is m by 2L plus 2 pi r. So lambda is nothing but mass per unit length. Now this crawler belt is moving with pure rolling. So this is a situation of pure rolling. That is the B is equals to R omega. So this crawler belt is moving with pure rolling. So this is a situation of pure roll. Now we will discuss the first part, part BC. What is the kinetic energy of part BC? Can anybody tell me? So let us say I am interested in kinetic energy of part BC. What will be the kinetic energy of part BC? You think yourself, give me the answer. This is a 1 second answer. If you understand, you will give the answer. You have to apply the concept of pure rolling. In the pure rolling, what happens to the point of contact, velocity of the point of contact, the lowest point velocity? What is the lowest point velocity? Yeah, you are right. So you see, in this case, the lowest point velocity is 0. So all these points, so this mass, all will have 0 velocity, because B point has 0 velocity, C will have a 0 velocity. So this means all these have a 0 velocity. So kinetic energy of part BC is half mv square. Mass will be there, but velocity is 0. So you will have kinetic energy of part BC is 0. Now can anybody tell me what is the kinetic energy of part AD? You think yourself. Yeah. So now the topmost point has a velocity 2v. Did you remember or not? So this has a velocity 2v in case of pure rolling. So mass will be half. Let us say length is L and mass per unit length is lambda. So this is half m. V is 2v. So this is the kinetic energy half mv square. So 4v square by 2. So 2v square into L into lambda. So this is the kinetic energy of part AD. Now we have to find kinetic energy of APB, and that is the important one. So we have to find out the kinetic energy of APB. So this part, and this is like a difficult one. So you have this part. Are you getting? We have to find kinetic. So this is the belt. So this is A, this point is P, this point is B. We have to find kinetic energy of this part APB. Now how we will do this one? So what we have to do is, we have to find what is the velocity of one point, this point, and then I have to integrate this one. So I will give you some hint. So let us say this angle is theta, center of mass is going with velocity v, and this is moving with angular velocity omega. Omega is nothing but v is equals to r omega. So this is the case of pure rolling. So this point will have a velocity v in this direction, and this point will have a velocity in this direction. I have already discussed in the class, this velocity will be omega into r, but omega r is equals to v, so I can write this velocity as v. Are you getting or not? And now let us say, so if I see, sorry, what is this angle? So this angle is theta. So what will be this angle? You try to find yourself. If this angle is theta, what will be this angle? This angle is again theta, because this line have a perpendicular to this line is this. On this is the perpendicular, so this angle is theta. Are you getting? If you are able to understand, then I can draw here itself. So this angle is theta. Are you getting? So B will have one component in this direction, B cos theta. Let me make another diagram. Some of may have some confusion. So let us say I will make another diagram. So I am finding resultant velocity. So I think you have copied this one. No need to draw the next diagram. You can see yourself. The first diagram is enough. Now I am considering this point. This point has a velocity in this direction, that is r omega, and r omega is nothing but v. And this point will also have a velocity in this direction, that is v. This angle is theta. So I am saying this angle is also theta. So this is v. So in this direction you will have v cos theta, component of velocity, and in this direction component of velocity will have, that is v sin theta. So what is the resultant velocity? So in x direction your velocity is v minus v cos theta. In y direction you will have velocity is v by, that is v sin theta. Now resultant velocity of this point is vx square plus v by square. So v square, resultant velocity square is, I need v square, that's why I am not taking root, v minus v cos theta whole square plus v sin theta whole square. So what you will have? So from here you will have, so let us say you will have v square cos square theta plus v square sin square theta, that is again v square, minus 2v square cos theta. So you will have, let us take 2b square common, then you will have 1 minus cos theta. Are you getting? Up to this point of time, I think all of you are able to understand. And if you are able to understand, now things are very easy, nothing to do. Now you see, I want to find out the kinetic energy. So let us find the kinetic energy of this one. So how will you find kinetic energy? So you have this mass. So let us say, consider the crawler. So you have here. So what I am doing is I am considering this point. So small mass here. Velocity I know. I have already calculated what is the velocity of this point. What is the velocity of a small mass at point P. Now mass if I know, then I can multiply by velocity. So let us say small mass here you have dm. So if I have here at angle of theta, mass, small mass we have, that is dm. So this is the angle of theta we have. Are you getting? So at angle of theta the small mass is dm. So what will be the kinetic energy? That is half into dm into v square. Are you getting? And v square I know from here. So this is the kinetic energy. If you have any confusion, I can write velocity whole square. So half into dm. What will be the dm? So this angle is theta, so this is d theta. So this is r d theta, and let us say lambda is mass per unit length. So this is r d theta into lambda. You have to understand yourself this. If you are not able to understand how I am writing dm to this, you are having a serious problem. You have to learn a lot. You have to read a lot. Now velocity square. Velocity is 2v square into 1 minus cos theta. So this is simply, we will have lambda r 1 minus cos theta d theta. So this is the small kinetic energy of this. If I want to find total kinetic energy, I have to integrate, and I have to integrate theta from 0 to pi. So this will be integrated from 0 to pi, kinetic energy from 0 to k. So kinetic energy in this case you will have, I think you have copied this one, lambda into r, and integration of 1 is theta, theta from 0 to pi, so this is pi, and this is sine theta at pi is 0, sine theta at 0 is 0 also, so this will be simply pi. You have to check yourself, you are able to do this integration or not. You see what I am doing, integration of 1 is theta, at when theta is pi, this is pi, theta is 0, this is 0, so pi minus 0 is pi. Sin theta, integration of cos theta is sin theta is 0 at pi, sin theta is 0 at 0, so there is no point of writing sin theta. So you will have lambda r into pi. Now this is the kinetic energy of part APB. Are you getting? Now you see, the symmetry of the problem says the kinetic energy of CQD will be same as part APB. So kinetic energy of CQ will be same. So kinetic energy of CQB will be same as lambda into r into pi. Are you getting? So what is the total energy? So total kinetic energy of the belt, total kinetic energy will be, now we have to add the 4 part. So total kinetic energy, you see here we will have 0 plus 2b square L into lambda. So we will have 0 plus 2b square lambda into L. I also have, I think, let me check, yeah, 2b square lambda into L plus kinetic energy of this lambda into pi r plus 2 times I will have. So let me write lambda into pi into r plus that also lambda into pi into r. So I will have total. So let us say if I take 2b square, I have to multiply by b square also. I think somewhere I have missed b square. Yeah, here. We have missed b square here. So there is a v square here. There is a v square here. I should have v square here. I should have a b square here. Are you getting? Are you getting or not? So I have left this v square. Here also I will have a v square. Here also if you want you can put a v square. Are you getting? So now if I take 2v square common, because this plus this will have 2 times this, so if I take, let me write 2v square lambda L plus 2v square lambda into pi into r. Are you getting? So if I take simply, let us take simply v square common and lambda, so I will have, I have to use a next page. So I think I will not use the next page, but I have to use now. So total kinetic energy is, if I add v square, if I take v square common, so we will have lambda also common. So we will have 2L plus 2 pi r. And this r, sometime I have written this capital R and sometime I have written the small r. Both are same for me. You can convert into a small r, as so for me r, capital R is same as a small r. Sometime I have written capital R, so I don't have any confusion. Both are the same r. Now you see, in the first I have seen what is the lambda. Lambda is nothing but, you see here we have defined lambda is m by 2L plus 2 pi r. So put the value of lambda. So lambda is m divided by 2L plus 2 pi r into v square into 2L. So this goes out. So now the kinetic energy is simply mv square. So we are doing so many mathematics, but the final result is very simple. So if the collar belt is moving with velocity v, that is the pure rolling, no slipping is there, the total kinetic energy will be simply mv square. This result you can remember. So crawler belt will have a kinetic energy of mv square. Are you getting? So I think all of you have copied this one. This is a quite good problem. This problem covers, what the concept this covers? This covers the concept that the in pure rolling lowest point will have 0 velocity, highest point will have 2v velocity, and a point in the circumference will have 2v square, that is the velocity square will be 2v square 1 minus cos theta. And then you have to, another important point you have, if you want to find out the total kinetic energy, these points will have not same velocity, these points will have different velocity. And that's why you have to integrate to find out the kinetic energy of this part. So in this question we have a idea of velocity of different point on the circumference. In case of pure rolling, what are the total velocity of different points? That's the only thing you have to know. Let's discuss the next problem.